Hello everybody and welcome to another Reactor live stream. So good morning, good afternoon, good evening, wherever you're watching this from. This is going to be a really, really good fun one for you to be involved in today. I'm really excited to have our presenters here. Before we get into this, I just want to go through a quick code of conduct. So before we get into the session, please take a minute to read this. We are all here to learn. We're here to be respectful and to help others sort of be prepared to ask great questions, understand people's differences, go through all of this together, and the chat will be open throughout the session. We encourage you all to participate and ask questions. So I am going to bring up onto the stream Cyrus and Jerry Lee, who are joining us here from Hong Kong.
Hello.
How are you doing?
I'm good.
To have you here.
Wow.
Yeah.
So this is the first episode of 4. So there's going to be a series that's running throughout the rest of this month and into next month, so October. And today we're going to be talking about creating your Azure infrastructure with the cloud development kit for Terraform. So all about infrastructure as code. So declarative languages, imperative languages, understanding the differences and seeing what you can do with it in Azure and sort of how you can automate and help, expand your development environment using these sort of tools. So I'm going to hand it over to Cyrus, who's actually going to be taking the bulk of this presentation, and I'm going to hand it over to you. And I'm going to stay on the stream, and if you have any questions, put them in, and we'll help answer them throughout.
Yes. Okay.
So Cyrus, I have your slides on the screen.
Yes.
If you can see.
Okay. It is. I can control the screen now.
Yes. Yeah.
Okay.
You can do that now.
Hello. Let me begin today's talks. Good morning, good afternoon, everyone, and hello. This is Cyrus from Hong Kong, and today we would like to share a topic about something interesting. It's about infrastructure as code, but using something very popular, something called the cloud development kit. In other vendor is very, very popular. But now I would like to share is how to use this technology to with Terraform together and building infrastructure with Azure. Okay. And just my background. My background, actually, I'm a senior lecturer of a technical institution in Hong Kong. And it is not university. It is a very, very practical vocational training institution. And actually, I won a 2-year high diploma courses. This is cloud major program. It's called the Cloud and Data Center Administration. And the first program provided AZ 104 training in Hong Kong. And then that this is Carl Arrogay here, and just say hi to your guys. And I don't speak too much for him. And then he is my student. He's Jerry Lee. He is a member of our project team, and he is also some Azure owner, Azure certificate owner, and working as a cloud engineer in an international consulting firm. And he's loved to play the AI automation car, something like Tesla, and win a lot of competition globally. And today's agenda is that first of all, I would like to introduce the problem about infrastructure as code, and also the option. The second is the option of doing infrastructure as code in Azure, and then a bit background on HashipCorp Terraform, and then introduce the cloud development kit for Terraform, and then I have a quick demo about doing the live coding of using CDK-TF tonight, and also I have some coding tips since this is very new technology in the domain, and also especially for Azure. I have some problem I want to share here, and then I have different application using the CDK-TF to build different application. I can show you some of the application code review so that you can understand how to use CDK-TF to build something very simplify your infrastructure a lot. Okay. First of all, I would like to introduce the problem. If you are using cloud for a period of time for the beginner, you will mainly focus on using the portal, your mouse and keyboard to create everything manually. And this is something for the beginner. If for production of it, do something very rapid, or we repeat, it will not be great. First of all, the main problem is that automating infrastructure, you have something called all or nothing. This is something my experience that if you do something manually or scripting, not using infrastructure as code tools, you may have the possibility to create something in the middle, and then the second half is not here, and then it will keep you have no idea what's going on. You will prefer something is all or nothing. Just create everything for me, or create nothing. And then the second point is that we want to infrastructure, not just create the infrastructure. We want to version control my infrastructure. I want to know the change of my infrastructure through GitHub. Something do everything. It's just a document. Use a code a document. Document my cloud infrastructure. And firstly, and we want to move our infrastructure or clone our infrastructure to different project, different subscription, or maybe share the project to other. If you need to a lot of step to ask people manually to create it, it will not be feasible or easy to replicate your work to different subscription or they let different people to use it easily. And then lastly, you want to build something like a package or a library so that you create your cloud application like a Lego. You just plug and play, plug and plug and play. No longer doing something like a repeat and repeat. Can't reuse it. And the beauty of cloud computing is that I can do everything as code. And we can get rid of all the physical constraints to create and manage IT infrastructure like a program. This is my experience on using cloud. This is something I very happy is that before using cloud, using cloud is quite complicated for the infrastructure, but now everything I can program it. And now if we move to the section is the compare about the infrastructure as code for Azure, the different option and consideration. First of all, you may see a lot of GitHub repo or source code. It will be using ARM templates, also a bicep template. You have with it, you use it, will be happy. But if you try to write it or create it, it will quite tedious. Since this is a JSON object, actually, you just manually to write JSON, but treat JSON like a program. It is very difficult to write it, but using it is quite simple. You can one-click deployment. And then upgraded, you have got the bicep. Bicep, actually, if you compare the syntax, you will feel it like Terraform. It's similar to Terraform, but you can do something like that. If you run something in Terraform, you need to run the program in your local computer. But if you run something all in Azure without a computer or executable, you just use bicep, then you upload the template there. You can execute it directly, no external tool required. And then you can think about the ARM template or bicep. It's something like HTML. In general thinking is that people create a cloud is something like writing HTML, just the script. There is a resource group, and then inside resource group got a network, got a VNet, got a subnet, got a VM inside. It's very similar for writing HTML. You got a table here, table inside a table. You have first row, first have image. The idea is very similar if you use this kind of tools. But the syntax is not easy to pick up, as somehow the language is JSON is not good. And then another idea is that some people will prefer to use something like scripting to for example, your command line CLI to create resource one by one. This one is just I mentioned before. It will be a problem if you run the script in say you have 20 lines of script, but you run the script in the middle of line 10, it got a problem. You will have the resource in the hardware, but the second half is not here, and then it will still use your account resource and use your credit, use your money. It's really difficult to manage. Okay, another option is that you will see someone to write some wrapper. You can think about is it something like PHP, okay, old school PHP. The style is that you use one programming language to try to use a string approach to create another text file. Like, for example, HTML is PHP HTML. Or someone will try to use this kind of method to create a bicep template or create a JSON file. This is the beginnings, but this is still very difficult since this is not, the main problem is not Johnny type. If you write program, if you write something string append, you will at the end you will got some problem, and then you will difficult to debug and hard to make doing something very in the large scale. And another tool is that you may know something, you have to do some tasks to create your infrastructure, not inside the cloud as well. For example, you want to have a Spark application, you want to write a script yourself, and then the infrastructure as code. You want to also have the deployment, the build process, and upload file, create database. If you want to use Bicep or ARM template, it will not easy to do it since you have some part of logic you need to run a program, but you want to wrap it in as a infrastructure inside infrastructure. It will not be easy to for more of the system. Okay, that is the reason why HashipCorp Terraform coming out. It is a solution to help to solve a lot of problems in previous slide. For example, one of the powerful part of the Terraform is that you got a lot of provider. You can even use Terraform for multi-cloud, for GitHub, control your GitHub, anything you think about it. You find someone write a lot of open source project. This is a provider. Once you install the provider from Terraform, then you are able to have a single code base and then control everything you think about, from even VMware, even multiple cloud, different cloud. And the second point is that this is something for me is very useful. I want to have something called configuration drift. By default, the design of Terraform is something like a shadow. You have a shadow in your computer, and then the real cloud is just something in pair. It is something like synchronization. You can have a synchronization between your Terraform and your infrastructure. This thing is nice, since someone may go to Azure portal or CLI or something. They modify your infrastructure. For example, they open the firewall. Okay, you want to reverse their action. In the past, if you are also not using this type of tool, you difficult to trace. But by Terraform, you can just try some of the action. If it is managed by Terraform, not outside it, it will be able to synchronize and then recover the different of settings. Then it is something like DevSecOps. You can have this is very helpful. And then also the syntax is much clearer. Since this is something a kind of programming language or language called HashipCorp corporation language, something. It will be simplified than JSON a lot, and then it's easier for you to write it and then create resources. And also you can have something like what I mentioned before. You want to have some embed of your infrastructure step or action into a program, for example, Shell script or Python to do something, but you want to also include as the part of your infrastructure. You can also include it very easily. Seeing Terraform is running in your computer, you can wrap it with enough resources, then you can call a lot of command line, a lot of program, whatever you like. And this is also modularized. Since the modularization, you can always configure and reuse your program easily. The slide have something blocked, but behind the slide is no, it's okay. It's something mentioned before. For example, here, this is a sample of PHP. Okay, you can think about is this is not good for the situation. If you, as I mentioned before, you write to one language to generate another language, it will be quite tedious. And the logic here, something like Terraform, as I just mentioned, there's something like synchronization. Actually, you have the step called pan, and then create also apply, and then it will something destroy. And actually, in the behind the scene, this is a shadow. This is a small database file in your computer, or you can use Terraform Cloud to store it, and then you can have a shadow in your infrastructure. And today, I'm not talking about Terraform, since this is a lot of expert on Terraform. I'm not very expert on Terraform, and also you have a lot of information. But both of the issue about something like Terraform or PHP is really designed for non-programmer to write code. The idea is really great. Since if your infrastructure guy is someone from networking domain, they never write program, but they will feel free to use accessible Terraform. Those are tools they feel is comfortable, since it's very easy for them. But difference is that if you are someone is full stack developer, you are very good at programming, you will feel that the syntax is not powerful enough. Yeah, since this is make you easy, but if you are a very good programming guy, you will find there is no inheritance. You are used to a lot of OO design is not there. You will feel it is very limit your programming style and application. And also, if it is possible, it will be great for developer. If you are from C# background, OOP background, you want to model the Azure resource as a classes. It's very good. It's very easy. It's quite fit into the domain. You just model different Azure resources as an object, as a classes, and then just write program like OOP. And for very complex logic, you find that command line is not good, and Terraform will become very long, and not powerful enough, to be honest. Some of the activity, some of the action you want to do is you can very easy to do in Node.js or TypeScript. But if you want to do it in Terraform, it will be very difficult to do it. At the end, you have to write a program, and Terraform pull a program, and they give you the data. Why not write the program directly? Okay. Terraform wrap the Terraform and abstract everything is the idea. Now I would like to introduce the CDK Terraform. You see the diagram here is the design of the design of the logic is that you are writing a high level programming language. For example, TypeScript, Python, Java, C#, Golang, and then is it cross compile, and then you will generate the Terraform for you. Okay, so you just if you are a programmer, one of the languages should be you should familiarize it, and then you just write your program you like, and then don't have to deal with the low level Terraform at the same time. And also, is it actually for the library themselves? Is it something called cross compile? Is it in TypeScript, and then it's use a compiler called JSII to build the wrapper, so the different programming language can use the library together. You can also write a library and then build with this compiler, and then your library will be used by multiple language. For example, you write in TypeScript, you can build it with, you can let C# to using it, and it is become the wrapper and abstract the Terraform. Here is the high level architecture. For example, for you, I will show the demo. You need to init your project, and then you start to write your program to create the cloud infrastructure, and then you will call a command called CDK-TF syn. Because for the synthesis, it will synthesize your convert your TypeScript in OOP manner into a single very long JSON file. Actually, the Terraform also supports JSON format. It will become a very long JSON, and then you finally you will through the Terraform and Terraform provider to run the CDK-TF command. It's just call Terraform, and then use all of the provider there. You can have the single code base to have multi-cloud solution with OOP programming. Here is some basic background for the generator. As actually the CDK-TF, why is it so powerful? Is that Terraform is upgrade very fast. Yeah, you see that every week I've got some minor update and a lot of provider they update all the time. And but the CDK-TF actually is a code generator. It will reverse engineering. You can just update the this is called a CDK.json file. You just update this file with different provider you want to use it from Terraform. Then you run the command. It will reverse engineering to generate the code for you, so that you can use Python, you can use TypeScript with the power of Terraform. Okay, this is some experience from me, but I still wonder why they may have some changes in the future. If you install start create a Terraform CDK-TF project, the last command will show you that they will ask you to install something. Okay, since they have the wrapper for the provider for different cloud provider, for example, AWS, Google Cloud, Azure, and even Docker. You want to control it, you just click the npm install, then you will able to use different cloud together. But from my experience, that this is pre-built library is sometimes outdated. Okay, outdated is if you want to use the latest Terraform provider, you sometimes will prefer you generate the provider yourself instead of install their library. This is my experience. Sometimes I found the library don't have the latest API for me to create something. Also, one of the libraries is very common already using it is Azure Active Directory. Okay, you want to do the role-based access control logic, and then you need to import the library. But if you do this uses command to install the preview library, there's no Azure AD support. At the end, both my project, I will build we will use a generator to create the provider myself instead of using the built-in provider. Okay. Yes. And the application architecture. Yeah. Since the preview provider, the preview provider, you can use this, but the overall you will the high level you will have a application. Okay, we will so called a app. A app actually will include you can include multiple stack. Okay, stack, and then stack will include a lot of resources, and then every resources will map into a construct. A construct is the code generated into TypeScript, into C#. It is the hierarchy. Then and you are able to have an application with multiple Azure subscription, multiple cloud, even the hybrid cloud in your data center. If there is Terraform provider for you, then you can do it. And also, if you have some code base already in Terraform, you don't want to manually to type in all the code again, you can use the command line tools to do the convert your Terraform code into the C# code here, or other language. You just train the parameter. It is convenient, but for myself, it may not be optimized, since the generation of reverse engineering is still using the thinking of Terraform. The Terraform is somehow look like HTML, okay, but now you are not you have C#. If you directly generate, you will find that you have some resources to replicate, and then if you look into it, you use a loop, but it will generate not looping. It just directly help you to convert the code one to one mapping. You need to optimize your source code after your converter to help you to generate the source code. Okay, some of the definition of the resources, and this is some methodology, some terminology for CDK. CDK is built on the smallest element is so-called construct. Okay, a construct we will have different level granularity. Okay, from the generator. Okay, from the generator, CDK-TF generator, it is somehow it's called the layer one. We will call level one construct. Level one construct. The level one construct actually is just a very low level one-to-one mapping. For example, you want to create a storage account, then it will give you all of the setting, just low level, where all setting. For example, the storage classes, the skill, it will be a string value. Okay, skill, different region, everything is skill, a string value. Since Terraform is like that, not the problem of CDK-TF. The problem is that there is no enum in Terraform, but the generator come out since the generator there's no knowledge on Azure. They don't know the list of region. They don't know the skill, the option of different skill. So they will give you a string value, so-called the level one construct. And it will be okay, still okay, since we already trained from the JSON into C#, that you will feel writing this code is happier, since auto-complete will be very, very powerful for level one construct if you're typing the code. But for better, but somehow for layer 2 construct, there's a definition for CDK method terminology. The level 2 construct, actually, it will group the still a resources, but the resources will somehow like object or within the program. It will quite the way it classes. The class will have some behavior, so there is somehow you will have some method, there's some domain knowledge inside the classes. Then the user can be used very straightforward. For example, you may want to have a storage account, okay, block storage account, and then a construct called add file. They just put the file path here. It will, when you create the infrastructure, it will help you upload the file to the storage account and then become a website. This is somehow called layer 2 construct. But at this moment, to be honest, for Azure support, there is the layer 2 construct is very, very weak. Since layer 1 construct is reverse engineering from Terraform, but for layer 2 construct, actually, it requires some of the developer or open source developer to contribute it. Otherwise, it will not have layer 2 construct. There's no resource at this moment, no team to help in Azure to write it. There's the reason there's no layer 2. But for myself, actually, I jump from layer 1 to layer 3. I start to build some layer 3 construct. Well, the level 3 construct actually is become a pattern. Okay, a pattern. For example, here's a last piece of application. You may have a application called myself. I create a construct called single Azure IoT device construct. It will be you just a single line of command, create a class. It's a very short parameter. A few parameter, you will have a Azure IoT storage account, Azure function, and then to process the IoT data to remote control something. You embed a lot of Azure resources and Azure service together by a single construct, become an application. This is the layer 3. For our team, we are strong from layer 1 to layer 3. Since layer 2 is very difficult to develop. Yeah, it takes a lot of time and manpower. Okay, here is my design of library. For myself, we mainly use TypeScript. This is our experience. Since although CDK let you to use a lot of programming language, but from my experience on using CDK from not Terraform, the old one as well, the language support for the purely TypeScript will be much better. Since it's you just cause compiler to compile the TypeScript into Python, into C#. Why don't you TypeScript directly? It will be the document, the auto-complete, everything will be better. And then you will view the source code. Since all the source code is Node.js, wrap the TypeScript, you can view all the source code easily. There's a reason why we are mainly use TypeScript. And also, we provide 2 libraries for our project. The first library is the provider. As the provider, I mentioned before, actually there's a built-in provider from CDK-TF team, but they are not really provide a lot of wrapper for Terraform. And no different from your generate or source code. Why not you generate myself? Yeah, generate myself will be full control for myself. I can control all of the version. And then a library version, and then dependency, I can control everything. And the lower level is the provider. And then we drop the common construct library. For example, I will show you some library we wrap before. For example, some serverless application, some container application, some IoT application. Just make use of the provider ourselves, and then we control all of them. And then our project will build on top those 2 libraries. Since you need to reference both of them, as your projects may not do everything within the common construct. You may want to build something very low level. For example, I do want to have a bucket, have a storage account myself, and then I want to configure everything low level. And you will still need the providers. That is the project design. You will depend with this. It will depend on 2 of the library. And at this moment, I generate all of the common library here. The good point is that it is very easier for you to use. The bad point is that the size is so big. This is the problem of Node.js. Actually, Node.js is very big. You got 100 megabytes JavaScript, but I have no idea how to trim it down. But at least you will not always download it. To be honest, you download the library once and then you build your application. So it's fine. Okay. With the time, half hour. Okay, set up the environment. I will want to just a demonstration for my environment to for the development. I have a Windows machine, Windows 11 here. I just want this command to install the chocolate package manager, and then install this kind of tools, and then insert the tools here, and then log in my Azure CLI, and then I can do the CDK-TF Terraform application. Okay. Here is a few commands to generate the application. First of all, I have to install the CLI globally. Otherwise, I can't use it in my machine. And then secondly, you in your folder, you just initialize your project. You can train here from TypeScript, C#, Python, whatever you like, and then install my library if you want to use my construct. Okay, I have some construct pre-built for you. You want to build some application, just follow my setup, and then you can have the construct. And one of the very important points, don't miss, is that if you want to use the library generate reverse engineering generate from Terraform, you need to have this parameter skip validation. If you forget it, it will always have an error, but you have no idea what what's going on. Okay, this is a very important point if you want to doing CDK Terraform. You just always put this parameter here. Will be happy. And then another trick is that remember there's a TypeScript. If you install some library, you find the autocomplete not working, you just restart the TypeScript server, and then your autocomplete will be working again. And how to create a project, and this some step if you want to create a CDK-TF project. This is no different from Terraform. You first of all, you need to have a provider. Okay, you write Terraform, you know you what provider you want to, you have a provider, and then keep the default parameter there. For example, subscription, tenant, you put the ID here, put the key here. And then you start define your resource in TypeScript. And then you log in with your Azure account, AZ log in, and then set your default subscription. If you don't put here, don't put the subscription in the provider. You set the default subscription. And then you call the CDK deploy, CDK-TF deploy. It will actually Terraform just call the Azure CLI at the background, maybe. Most likely just call them. That's the reason why you log in the Azure account will be okay. Okay, and then you want to deploy, it's CDK deploy, and it will give you everything. And then you want to, it will ask you confirmation. If you're doing the development, you always ask you confirm, and then you go to take a coffee and get a coffee, and then come back, oh, do nothing. It will be very destroyed. You know the deployment will take time. You want to have a break and then come back, oh, wait again. You always, if you're doing the development, remember to put the parameter auto approve. Then your deployment will not ask you a lot of questions. It just help you to deploy it. And for the output, somehow, sometimes the output have some sensitive information. For example, your password, your key, something. You want to read it. The straightforward way is put into the file, and then remember to put it into git ignore. Okay, you read the JSON file for your secret. And when you want to destroy the stack, it's just straightforward. Like Terraform, that CDK destroy, it will destroy the stack. Maybe I put the demo at the end, since I want to give some time here to explain the logic. I talk to everything and then do the demo at the end. And okay, some tips when you develop Terraform, you can always if you would do something you want to quickly to edit the your source code at the same time. You want since for myself I put the package into the npm repo. But for local development, you can modify your package.json, and so that you just reference different project at your local computer. Then it will reduce your time to build the project. That's the first tip when you develop something on CDK-TF. And also, maybe this is a kind of feature, not incomplete feature, or you can think about is it bug or not. This may not be, but in general, you can do everything on Terraform with CDK-TF. Since there is the API called that override. Okay, you can add override to anything that output to Terraform. For example, this is something very, very common. You want to use null resources to run some command in CDK-TF. You will find that the generator will not give you the access of this API called local execution. Okay, local execution to run a command. Then you just override it. And if you find anything have bug or anything not support, just do add override. It will already working, since it will let you touch the low-level JSON format and then just modify the JSON directly. Okay, this is another tips. Since not always, but occasionally the API is incomplete or the API have some issue, you will override. Oh, and this unable to pay it. Actually, this is maybe I'll do it the demo myself. I can show you how to develop the Terraform CDK-TF. You just can use the quite common technique in Visual Studio Code, Control-Click. If you find some API, you type it, the autocomplete come out, you don't know the document, you don't know what happening. It's just in Visual Studio Code to Control-Click, and then at the end, you will got the Terraform document, and then you can read the Terraform document and answer your question. Also, remember that when you create something, this is not about the CDK-TF Terraform, but in general, you will find if you hit something random manner, for example, you create infrastructure, sometimes it will work, but some deployment it will have error. You do think about the timing issue. Okay, since for especially for Terraform actually it's just called the command line where continue call the command line. It's something time dependent, for example, network dependent, network latency. The environment, the cloud may have some different latency randomly. Okay, if you find this kind of problem, remember that you think about using depend on. Okay, but if you find it's working sometimes, not working sometimes, this is my tips. Think about what resources, but it depends on some of the resources it will automatically help you to handle dependency. For example, you create a subnet in a VNet, it will automatically, since you have a reference for the VNet ID to the subnet ID, then you will know that the VNet must be created before the subnet. It will automatically help you to solve the dependency problem. But if you're doing a lot of Terraform, you will find that the command line they have no idea. Very important, since some of the action will be in command line. They have no idea how long it take. You need to hold it. Then you need take some depend on. And then this one is the custom resources. That's just what I mentioned. Even you can do the CDK-TF with Node with TypeScript, but when you embed something into the infrastructure, you want to create something causes custom resources. The idea is it's abstract, not something like a virtual machine, something like subnet. Maybe this is a IoT device or IoT a key, okay, a private key. You can consider this is a IoT key. Then from the logic point of view, you can think it is the API call, but from the designer, I think this is a resources. Then you can wrap these resources as a custom resources. Then you can let a IoT equipment API key become a resources and then managed by the infrastructure as code tools Terraform. This is the idea of custom resources. And somehow you will write some script to create something. This is the life cycle, the create life cycle, the update life cycle, the delete life cycle. You just try to fill in this life cycle API. Then you can mock something like custom resources. And also, something I hit before is that you will find some of the classes generate from CDK-TF. It will suffix with a. Okay, you need to use this. Some as I think because of some of the API is from Terraform, their naming is the same, but two output become they have to suffix a so that it will be able to reverse engineer to generate. If you create something, you find that you can't deal with. Okay, you want to leave something, but the autocomplete say this is constructor is not able to leave it. Some error like that. You just try to suffix an a there. It will be let you to create something. But why this call a, I have no idea. There's a tips. And then finally, something you are users in Terraform is that some of the Terraform resources, for example, you want to output a connection string. Okay, the primary connection string of the storage account. Well, this is something very sensitive. By default, Terraform will not let you to do something like that to get the key, to get the sensitive information outside. You need to wrap in Terraform, you need to put a function to wrap it. But if you want to use this in CDK-TF, remember all of the function is there. You just need to import the fn doc, then you can use all of the function. Yeah, this is something quite useful. And also, when you upgrade, okay, when you upgrade the Terraform, I say upgrade the Terraform or upgrade your provider, both of the case will hit this error. This makes sense. See, this is not about CDK-TF. When you upgrade the Terraform, upgrade the provider, actually for the Terraform, you go Terraform init, actually it's just download the binary, the Go binary, Go application from internet. This is a version, certain version. This is a download binary. When you upgrade your provider from your config, you need to download the library again. This is when you hit this kind of error, hit this kind of error in CDK-TF, you need to go to the CDK-TF folder, and then we run the Terraform init to download the provider. Then you will resolve the problem. Okay, and here is some of our construct library. And here's, for example, we have a lot of projects. But my project mainly on Azure Functions, since we don't want to, we are ready to run VM or something. We wrap the high level construct. For example, I want a Azure Function in Linux with C#, in Windows with C#. I just need to create a new this construct, and then provide the Visual Studio project C# project code here, the folder here, and then it will automatically help me to create the Azure function, help me deploy everything, config everything. For IoT applications, since we have several IoT applications, we want to have a application that with Azure IoT, and then the Azure function to handle it, and then with the storage account to store the data. Then I wrap a construct to do it a single line. If you want to inheritance, okay, the parent and then the child version is more powerful. If you want to do something streaming for the IoT, okay, you are better to put the output to Event Hub. Then you can have a stream, and then you can do more real-time analysis. Then you can have another construct, and another construct is called as IoT device construct. Is single hardware, and then I want a key for that single hardware. For example, I have Raspberry Pi to control the equipment. I just one Azure application with one devices. Just call this function, and then we will create everything for you. Also for container, for ACI, we have application want to build ACI from Docker file and then deploy it. Then I just call the static container construct. It will help me to create the container in the cloud. And publisher is a abstraction construct. I create this construct. It will help me to publish my application. Yeah, and then it can use a different construct together. And finally, another one is called file share. I want to some kind of synchronize my file share between my local PC, local different PC and the cloud. And also for API management, this one is that it's quite common for our application. We want to have the range limit for the API call. We want to have a API key for different users. For myself, 100 students, I give 100 different API key to all students. Every student got one key. Then I want to create a API managed construct, and then give the CSV file as the input, and then I will create API to wrap the Azure function, and then generate 100 key for my student. And here is some code review, and let me look at 45 minutes is quite long, my presentation. But this is some application. This is what I mentioned before. This is an application about the Raspberry Pi hardware, and then the source code is here, and this is actually a single line of source code. But I want to share my screen. Hello, can you help me to share my screen, as the slide is hard and unable to click the link?
You're right there, Cyrus. Okay, so if you share your second screen, so if you just share your screen again,
okay,
we'll add it to.
Okay, can you see my?
Yep, we can see your PowerPoint.
Okay, yeah, and it's better since I want to do the live code thing or the code review. Here is the code review. It's quite straightforward. This is one of my application called the power control for my lab equipment. Actually, it is control the power. I just need to, here's the CDK-TF construct, and a provider, just I mentioned, I have a provider here, Azure, and then I just need to create a resource group. This is very OOP manner, and then I have one single construct called the Azure IoT construct. I just give a very basic information, just a resource group, and then I want to create a device for the IoT construct for the Azure IoT, and then I just put the ID here is the IoT construct, and then I give different setting to create Azure function, and then output different value with a for loop. Yeah, and finally, the device key is the hardware key for the Azure IoT. It's single device, and this is the solution for this architecture. For this architecture, a less than 100 line of code, and then you can have this solution. Yeah, and second example, this one is another talk we will share. It's called Azure Hybrid Cloud Environment. It will be something to use Azure IoT to remote control all of our computer at our school. And you see the architecture. There is IoT, event hub, different Azure function, storage account, and a lot of code here. I can show you the source code. This is also very similar to what I saw before. Yeah, this one, and also very similar. Just create the resource manager provider, and then set some variable, create a resource group, and then create a construct. Okay, but this construct is very similar to the last one, but this is event hub. Since I want to have the stream analysis, I want to have the stream processing, and then create a Docker image. I just Azure static construct, and then put different setting, put a key here, and I want to have the string, have storage account. Hey, you can use a looping, okay, or map or something like that. It's just high level JavaScript programming to create storage account in a like, for example, if there's just three Azure table, and then just create like that. And then I want to create a Azure function with this kind of setting, with the different ID, different setup, and then create a Azure function, and then to output the different settings here. Yeah, and then you can use looping to output other setting. And this is quite straightforward for this kind of thing. You can loop, you can if then else. Actually, you can do something in Terraform similar, but if you compare the syntax, you will feel writing TypeScript is much clearer and comfortable for developer. Okay. Yes. And lastly, this is another application we are going to share in the coming week. The next week will be this architecture. It's called the Azure Cloud Environment. You see the architecture there is Azure Function, storage account, Azure container image, resource scope, something like that. And you will see the very similar source code since we wrap everything as a construct. And the manner is quite straightforward, similar. Just create a provider, and then what you want to create is that since this project also needs Docker container, I will put the Docker container in Azure Container Registry, and then this construct will create the container registry, build the container, and store here, and then output the key, and then storage account here, looping to create different table, create different queue with a map function, and then container, and then we have a serverless. But this time we want to use Linux construct, Azure function in Linux, and then set up some role-based control. Okay, use a role definition here to let the Azure function to access the ACI and then output it. Yeah, and as you see, this also very similar. As this kind of architecture is not so regular, but if you wrap your previous project as a construct, you just need to minor train it or even reuse it or inherit it. Then you can reuse your infrastructure and build new application very quickly. Yeah, this is the idea of CDK-TF, the beauty of that, since you can inherit your previous project and let it evolution. Okay, that's a timing far over, it's a bit over one, still not the demo. But in the future, it is in the future, this is the idea. If this is possible, if there is some developer or resources from the community, it will be great if there is layer 2 construct to have the interface. For example, we want to have the RBAC string, no more string. I hate string. Since string, you will always have typo, capital character, lowercase, upper character, and then you will not be able to run it. You all want enumerator in TypeScript, enumerator in C#, and then no more ID management. let it auto-generate, manage in the background. Here's the idea of the source code in the future. It's possible. We want the source code like that. I want to create a source code. I don't want to fill the rest. I don't want to fill the ID. Or don't want to fill the name. Let it handle it. I need a resource scope, just say by enum, got the East Asia, this means Hong Kong. And then I need a storage account. Just put the resource group at the constructor and then give me a storage account. And then I want a database, it is serverless. Then just like it. It's inside resource group, put the resource group here. And then I want the block container from the storage account, just put in the constructor, create Azure function in a resource group, just put it here. And then I want the Azure function got the permission to read the storage account. Don't have to do anything on connection string, just put it here, construct the Azure function, ground it to write, ground it to read the database. And then finally, this one here, all of the code should be wrapped into a single line of code called the serverless function application, and then put the region, then done. Yeah, this will be this is called layer 2 construct and then wrap into layer 3 construct. If in the future it will be this kind of library coming out, it will be very great, and then it will be very much more powerful for CDK-Terraform. Okay, maybe take the time. Oh, we still have 8 minutes. But I'm not sure to do the demo or Q&A better. But for the demo, maybe I take a record or take a video to share to you guys later, so that you can just check out my video, or for the demo is maybe just leave 8 minutes here for Q&A. Okay, thank you.
Thank you very much, Cyrus. That was fantastic. That's a brilliant session. I mean, I really enjoyed playing with Terraform. I mean, I've sort of had the luck of playing with ARM templates, Bicep, and Terraform, and a few other things. But Terraform is by far, I think, one of my favorite ones, purely because you can post to so many different clouds, and there's so many different extensions you can have to it, especially with the CDK here. I'm also really glad that you touched on config drift. So when talking about infrastructure as code, config drift is actually a really, really big problem that people don't really realize or recognize. Is sort of like when you start making subtle changes to your repositories in your configuration files, and then sort of people don't pick up on that later down the line, it becomes a bigger problem. It kind of ends up sort of diverging kind of in a really quite a big way. So yeah, thank you for picking up on that one. It was quite a small mention, but it was also quite a big topic that you could probably talk about for a while. And also the syntax of code and infrastructure as code. So I always find that you're very right how it's just really not verbose. And being able to use something like this to write Go code or write C# or write Python or Node or JavaScript as such, and being able to convert that into sort of like an infrastructure as code, sort of how you would with an SDK for a cloud provider. So really, really similar, but it's a really good way to get the underlying mechanics of Terraform. So thank you very much for this. It's a really verbose session. I think for the next one, I think you should do your demo at the beginning of the next session. But before we get on to that one, because it's a really exciting prospect, we really want people to see this. But we do have one question in the chat from Andrew, and I'm going to put that onto the screen now. And it says, what is the best way to organize Terraform files? Do you have a different Terraform file for every environment, or do you group them, or do you group it per resource group?
Oh, this is about the question on Terraform. But for Terraform, normally we will design something like module. But for CDK-TF, we will group them as a since we do something like OOP. You will group something together. It's form an application. The direction is we call it layer 3 construct is direction. We group them. Will basis on the idea what you want to build the layer 3. For example, you see on my applications, for example, this is a IoT application. We will say, oh, the structure is that all of them will become a library. They have the IoT, Azure IoT, they have the storage account, they have the Azure function grouped together, and then form a application. And then also, we can publish the library, include the C# code. For example, the C# code is the logic to control the power of the equipment. You can wrap the CDK-TF, include the business logic, include the other application together, and then form an application. You just call single line of npm install power control construct. Then you can have not just the infrastructure, but also can include business logic source code there as the is somehow you organize it. Well, we will, for myself, I will think about the application more than the I will not think about that this is storage, this is database, this is compute. Or we are not think like that. We are think about the application more.
Brilliant.
Okay.
Thank you. That was a really, really good explanation, actually. I mean, personally, I actually group them per resource group. I do whenever I need to use them. So that's my personal one. Again, I guess kind of it can be personal preference as such, because I've worked in places where it's been like a flat directory.
I think that since this is, if you do something from if you take CDK-TF, your resource group does not matter. Since you already have the Terraform how to go everything, you can have multiple resource group. For example, I have some application to separate different resource group, even different subscription. Yeah, you can have multiple subscription, multiple resource group to form an application. It's common. So for enterprise or for a company, they may have a different department, have different subscription, but they want to have a big application to manage all the infrastructure with a single project. And single resource group will not be work for multiple subscription. That's the reason why the flexibility, you have a wrapper of Terraform or some CDK-TF, this kind of application, you can have different thinking on your design of your cloud.
Yeah, very much. It really depends on your use case in that scenario. Jerry, how are you doing? How did you find that? What are your thoughts?
He for himself, he will build. Yeah, he's Mastodon, and he's the developer on my team. And sometimes he will build. He will use the CDK-TF to build application. Then since we build the library from different students, and also myself, our team will create the base library. For example, we create Azure Functions. It's quite straightforward now. You may use Visual Studio, you may use Visual Code, but the setup is quite. It's not hard, but somehow we invent the wheel all the time. Now it's quite straightforward. We will just install the common library and then set the folder path, and then we will have a Azure Function application and then we just focus on building the source code, business logic, not the infrastructure. And also it will handle the deployment, handle the update, handle everything.
Thank you. Yeah, that's brilliant. Okay, so I'm actually going to throw up a slide onto the screen now. So I just want to say a massive thank you to both Jerry and Cyrus for putting this together. It's brilliant. So this, like I said, this is the first session of a 4-part series. To get to the series page, I'm just going to pop it into the chat now. So to sign up to the series page or the different episodes of it, you can visit that link there, which is that yes, that is the right one. So it's on our website. And yeah, so the next one's happening on the 22nd of September, which is next Thursday, I believe. And it is using Azure serverless functions and infrastructure as code to automate service creation, which is going to be a really fun one. Considering we're in serverless September here at Microsoft, we're really enjoying a lot of this content. So let's say thank you. And with that, I think we will end the stream.
Okay, welcome. Thank you very much. See you next week.
Goodbye.
Bye.
Thanks, everyone.
Bye.